Hello and welcome to the next episode on Carnot Cycle. So today we'll be looking at Carnot efficiency using TS diagram. Alright, so this is the TS diagram of our Carnot efficiency as we have drawn this in our previous video. Alright, so now we are going to be proving the efficiency of the Carnot cycle using this TS diagram. Alright, so I've already told us that the Carnot efficiency is denoted this is Carnot efficiency. Alright, this Carnot efficiency is equals to the work done, this cycle, work done all over the heat supply, all over the heat. Alright. So now you are going to note carefully that the work done in this TS diagram, that is the work done in this diagram, is nothing but work done is nothing but the heat supply, that is the heat supply minus the heat rejected. Right? Because this area seen here is this meaning of this QA is heat addition, which also means what? Heat supply. So the difference of heat addition and heat rejection give us the work done. So work done is QA minus QR. All right. So now, and we already know that our heat supply is QA, right? Now, the next thing is we want to find what our QA is and want to find what our QR is. All right, from the first law of thermodynamics, we know that heat, that is Q, is equals to what? Is equals to T, yes. This Q, let me use the Q, but I don't need T here. Let's just use Q. Q now is equals to T into change in S. So let's keep this. Now, we said our QA, right? So we can have our QA now. QA will be equals to T the S, that is T change in S. All right. Now, if we go to our TS diagram, now this is our QA. So we are having our QA at this at a state of 2 and the state of 3, and there we are having the temperature there to be, that is T2 to be equals to what? T3. So this temperature that we have here, we can either write it as T2 or T3, but let's take it as what? T2. So we are going to note that T2 is equal to what? T3 here. So QA equals to, let's take it as T into change in what? Entropy, right? So don't forget, the QA is between what? State 3 and state 2. So the change in entropy here is going to be what? S3 minus what? S2. So it's going to be X3 minus S2. All right. So let's apply this to QR as well. So QR will be equals to, now our QR is in the state of 4 and what? 1. All right. The temperature there, we have T1 to be equals to what? T4. So we have T1 to be equals to T4. So we can pick, either we pick, we have T1 is equals to T4. So it's either we pick T1 or T4, but let's pick T1. So we have T1 into, so the change in entropy now is going to be X4 minus S1. S4, S1. All right. So now the next thing is, let's substitute this back to our work done. So it means our work done will be equals to QA, that is the heat supply, that is heat added, going to be T2 into S3 minus S2 minus the heat rejected, which is T1 into S4 minus S1. So now we can now go back to our Carnot cycle. Now we know heat supply is the same thing as heat supply is the same thing as what QA. Added. All right, so now we can now therefore write our Carnot efficiency equals to work done. We know the work done is T2 into S3 minus S2 minus T1 into S4 minus S1 all over what? All over the heat supply, which is QA, and our QA is nothing but what? T2, but T2 into S3 minus what? Minus S. All right. So now, if we divide both sides, by T2 into S3 minus S2, we are going to have our Carnot efficiency will be equals to 1 minus having T1 into X4 minus S1 all over what? All over T2 into S3 minus what? Minus S. All right. Now, you are going to note carefully that from our TS diagram, we said our X1 is equal to what? S2. So we said S1 is equal to S2. And we said S3 is equal to what? S3 is equal to S4. All right. So now, if I decide to substitute for my S4, S4 is equal to what? S3. So this one we can write this as S3 minus S1. So we can have our Carnot efficiency equals to 1 minus T1 into our S4 is equals to S3. So we have S3 minus S1 all over T2 into, now we have S3 here minus S2. So and our S2 here, so let me write S3 minus our S2. Our S2 is equal to what? S1. So here we are going to have S1. So what do you observe? You observe that what is here will go with what is here. Then our Carnot efficiency now equals to 1 minus T1 all over what? So this is the formula for Carnot efficiency using the TS diagram. Because our T1, which is equals to T4, is the minimum temperature, and our T2, which is equals to T3 on the TS diagram, is our what? Maximum temperature. So 1 minus minimum temperature over maximum temperature will give us our what? Carnot. So this is how you can use the TS diagram to prove the Carnot efficiency. So we'll be using the PV diagram as well to prove the Carnot efficiency. And next, stay